your own virtual copy. Thank you guys. All right, so that's it. So systematic sampling. I hope you have heard about this term also earlier on. It's also known as interval random sampling. Why? Well, it just provides some sort of random sampling and it's based on interval, right? Unlike SRS, remember? Oh, you have to number everything in your population and then you have to generate random numbers some more. And then you have to select based on those random numbers, isn't it? Of course, random numbers between 0 and 1, you need to multiply by the population size, right? Is randomly selected. You do need to generate random number, but hello, please remember SRS. Oh, suddenly no voice. Oh, here. How about others? I am talking. I talk non-stop. Oh God. Okay. Me, okay, how about now? Is it okay now? You know what? I just stopped recording. No, it's fine. Okay, everyone, please focus, or you can do your own recording. You know how to do that, right? You can download this software, I think. You can do own recording at your desktop because apparently I can try again. You want to do the experiment? I try again to record and see if suddenly you cannot hear me. Okay, so now clear, yeah? Okay, so please focus here. Maybe I can record, but I haven't. Okay, hold on. I'll do recording on my screen here. It's probably blocking a bit, so hang on. Video. I'm gonna record full screen. Hold on, you have something blocking because I'm trying to record this manually. Okay. On air. Right. Okay. So just to recap, so systematic sampling is also known as interval random sampling. Focus, guys, this is very important, especially for your quiz and your test. Interval random sampling because of the interval, right? So we have to generate a random number just once, right? Is to select the first element. And after that, all the subsequent elements, so meaning that if you got 50, your small n equals to 50, for the first one, you will need to generate random number. And what is the general, okay, okay, let's say, I'm going to give you some analogy here. All right. Let's say your n equals to 1000, big N, and small n equals to, let's say simplicity wise, 10. Haha. Oh, no. Yeah, 10. Okay, guys, see that? I typed also in chat box. Right. So, how do you generate the first element? It's random number for the first element. You know, like so the first element should be, okay, let's talk about k first. What will be the k here? The interval. It's too big lah. Actually, no, I'm changing now. Small n equals to 50. No, why not small n equals to 100? Change already now, at least. So K is given by the big N divided by the small n, right? So your K is now K equals to 10. Okay. Others also encouraged to answer. Not just Alice answering. Okay, of course, I'll welcome that. All right. Okay, good. So we've got more answers. Now, if you want to generate the a random number, you want to select the first element. What should that first element be? Well, will it be between 1 and 10, 1 to 100, 1 to 10, It's up and from 1 to K, All right. Why is that so? You refer back to the examples in the slides, isn't it? Okay, now, so once you select that element, the first element, the subsequent one will follow whatever your K is, right? Okay, simple, well, simpler than SRS, I would think. It takes time also to generate random number. Of course, computers can do that for you, the multiplication and all that. But selecting is like, in some cases, you cannot afford to do the SRS. Now, let's read further. Okay, subsequent elements are selected using a fix. It's fixed, isn't it? Fixed based on K, right? Or what we call systematic interval, because you have a system every K, every 10, until the desired sample size is reached, until you reach your N. Okay, so in this case, the small n was 100. Now, the random start actually distinguish this procedure from the non-probability counterparts. Now, okay, take note, guys, very important, super duper important. In some cases, sampling frame is not used, or it's impossible since you don't have the sampling frame. Okay, so in such case, the target population need not be numbered. You do not need to number your target population. Comparison with SRS. SRS you need to number, isn't it? Yeah. And a sampling frame also is not needed. Okay. When you have such a continuous flow of population elements at specific locations. For example, patients coming into clinics, right? Or people going into the mall. Today not so many lah, MCO. Okay. So you can systematically select every eyes patient. Okay, take note, Sage use eyes. In our textbook, we use K. It doesn't matter as long as you understand the notation being used. Okay. Other examples are customers standing in line, queuing, or records in your file drawers, things like that. This part okay, guys, for the examples? Clear cut, All right. You know, you have your teamwork. Please be creative enough and think of your own example instead of just copying from textbook. Okay? Because creating, coming up with your own examples actually demonstrates your understanding and correct application, not just copying. Please, do not insult your brain. Your brain is very capable. Human brain, the most complicated, sophisticated creation ever. Right? Okay, now, what are the steps? Define target population. You calculate the sample size n. If there is sampling frame, then use it, or you have to develop your own sampling frame. If there's none, then no problem. And you have to evaluate the sampling frame. What if you do not know the target population? Right, people coming in the clinic. How would you know today how many people are going to come to the clinic? You don't know that, right? So how are you gonna compute your K? Remember, guys, if you don't know for sure something is uncertain, what do we do in statistics? We do this in life as well. What do? It begins with the letter E. And that's what this course is all about. It's what your whole learning, your degree program is all about. We do what? We estimate. Okay, so it can be estimated from probably the yesterday or the week's but then sometimes be careful like places, like shopping malls or even clinics, right? Agak-agak estimate, yeah, that's right. Malaysia is like agak-agak, right? Okay, yeah, but of course you come up with the best estimates. So if it's like the shopping mall or even clinics, it's probably you have to take the day's average. Okay? If you notice, right, and also talk to people working in the mall, they're saying that usually in the mall, right, most people count over the weekend, right? So you cannot really take the weekly average because you know, it will probably be overestimated or underestimated depending on your day. Because on Wednesday, typically for shopping malls, on Wednesday is when the least people go. So sometimes when I want to do shopping, there's no class on Wednesday, I'll take Wednesday off. Okay? And on Wednesday, they also have lots of offers. I know this from the perfumery in Parkson, kind of, was it in Queens Bay Mall? This lady was telling me on Wednesday, if you want to buy a good price for perfumes on Wednesday, because they have good offers on Wednesday. Just want to promote sales on Wednesday. On Wednesday, very small, low number of people. So depends on the day, all right? So you estimate, all right? So moving further down, then you, if you have the sampling frame, you evaluate the sampling frame, of course, for all of these possible issues here, right? Under coverage, over coverage. Remember chapter 1? Okay, multiple coverage, blah, 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 right? Okay, and then determine the number of elements in the sampling frame. If you know, yeah, cinema also got offer on Wednesday. It's the middle of the week, right? Okay. Calculate the sampling interval, I, okay, by dividing. And then randomly select a number. This is the first number for the first element. That's right. From 1 through I, or from 1 up until K. Yep. And then select the sample. So your sample will be, of course, the first one. And then, of course, R plus I, R plus 2I, or 2K, whatsoever. Okay. It's just a refresher. It's nothing new. Okay. Now, at a technical level, one might argue that this is not a truly random. You are only randomizing the first selection. That's why sometimes this systematic sampling is also referred to as pseudo-random sampling. It's pseudo only, yeah. But once they okay, take note. Once the first element is selected, some of the elements will have a 0 probability of selection. True or not? The one adjacent to it, right? Let's say I select number 8. Number 9, number 10 definitely will not be selected already. Yeah, because your K is 10 just now, right? Something like that. So what does that mean? It's 0 probability of selection. So it's unlike SRS. SRS equal probability of selection. Systematic sampling, no. Some elements will have 0 chance. Okay. Right now, certain combinations also, like this is I mentioned just now, elements that are next to each other, adjacent, not likely to be selected. Okay. And repeated, this is when repeated systematic sampling can be used, okay, or is recommended. Okay, guys, let's take a look. These are not in your slides, okay, but that doesn't mean that they are not important. I'm covering it here so it can come out in your quiz and also in your test. Okay, I think I'm going to add this in slides for next semester onwards. Right, so systematic sampling categorized into 3. So which one that we have covered in class, you think? There's linear, circular, and repeated. Usually in class, so far we've covered the linear one, Okay, and because this is the most frequently used. Okay, now, so for circular, okay, the name suggests that circle is circling. So what happens is just now for linear, we take number, your first element, right? Your first element in your sample, you take between 1 and K, yeah? For circular, you generate the random number. The first element is between 1 and big N. So if your population size just now was 1,000, so between 1 and 1,000, that means you do not start from the beginning. I mean, like, it doesn't necessarily that the starting point is somewhere in the beginning. Starting point can be anywhere throughout the 1,000. Okay, clear this guy, guys? The difference? Okay, so this is for circular. So what happens is that, let's say for circular, then I select, suddenly number 50. Oh, that's like in the middle already, right? Compared to just now, say number 8. It's for circular, so 50. And then I go on 50, and then plus 10, and 60, and then oops, of course you will reach 1,000 then, right? When you reach the end and you still have not achieved 100, which is your sample size. Then you continue. Circle lah. You continue go back to the first element in the population. Okay now? Yeah, that's why it's called circular lah. Give me some indication. Okay so far? Okay, good. Thanks. Now, so linear systematic sampling and circular systematic create a single sample. Now, repeated systematic sampling, as the name suggests, something is repeated. It involves selection of multiple samples and then combine a single sample. What does that mean? So instead of only choosing one random start, the first element, now you have several smaller systematic samples selected using multiple random start. That means you start at different points. You don't just start once. It's not linear, you start once, right? Between 1 and k. Circular, you also start once, but between 1 and the population size. But for repeated, you start at random multiple times. Okay? And then you combine those to make one sample. Now, as you suggest, as we would know already, right? This will be more time consuming, but it helps to minimize the effect of bias due to periodicity, okay, which is a pattern that occurs regularly in the sampling frame. Okay, yeah, right so far? Okay, been working so hard, yeah. It's already 10:36. What do you say if we take 5? After this, we go to the strength and weaknesses. Okay? Alright. If you have any questions, just put in the text in the chat box, yeah, so that I can go over it again. Okay, guys, take 5. Okay, I'm up. Right, you guys done some stretching already, yeah? Okay. Right, so shall we resume? Just a little bit more before we start to discuss. Okay, hold on, let me just resume recording. You guys hear me okay? Okay, all right, Afif is here. Okay, so just Wai Hong then. Okay. Okay, guys. Just now clear, or anyone still confused about the differences between linear, circular, and repeated? Yeah, I mean you can draw your little diagrams, you know, your examples, your etc. for more understanding. It's up to you. Okay, what are the strengths and weaknesses of systematic sampling? Okay, take note. Systematic sampling is most popular when it's impossible to use SRS. Yeah, SRS is a very common one, right? But when it's impossible to use SRS, for example, what? You don't know your sampling frame that day. Yeah, for example, what? Traffic, you know, all this traffic survey, probably, right? You don't know which car is going to pass through that route on that particular day, pass through the exit. You don't know, but roughly you can tell the population size, the number of vehicles passing through that particular exit on this particular day. I mean, on that typical day, not particular day, typical day. Okay. Right. Or also when your sample size is really large sometimes. Okay, let's go through the strength and weaknesses. Is this working fine? I'm scrolling. It's moving, yeah? No lagging, yeah? You can hear me clearly as well? Okay, good. Thanks. Now, table 5.8. Of course, you can read all the description there. I'm just gonna, you know, it's good. I usually do this table. That's like my favorite thing to do when learning. You know, strength, weaknesses, pros and cons. Because in real life, when I was working industry also, whatever your suggestions, whatever the proposed action, you must always come up. You must propose and you must also describe or anticipate. You know, the pros and cons, the advantages and disadvantages, the strengths and the weaknesses. Because nothing is perfect. And then you have to weigh. If you can quantify, then you will need to quantify. And usually at the workplace, you need to quantify in dollar value. Okay, if you say that it's less time consuming, okay, by how many percent? You know, you can just estimate now, of course. Yeah. And to estimate, don't just pluck the numbers out of thin air. You're going to have to look at previous record or typical. Yeah. Okay, whatever that you're learning is very useful in real world. Okay, come on guys. All right. Now, so unlike the other strength, unlike SRS, now, in the selection process is manual, as you can see, it's easier, simpler, less time consuming, more economical. Okay, but the weaknesses is what? If the sampling interval has got some periodic ordering, then the variability may be increased. Okay, and then next here, for the strength, the target population need not be numbered. Easier, right? So in fact, you don't even need, even without sampling frame, you can still do systematic sampling as we discussed earlier. Remember, the kth person coming to the shop, to the clinic, or things like that, right? Or passing through this exit, yeah. Okay. And if the ordering of the elements in the sampling frame is randomized, systematic sampling will just be more or less about the same. as SRS, yeah, in terms of the results, precision, right? If there's ordering, okay, and the ordering is related to a study variable, then systematic sampling is more efficient than SRS. Okay. And systematic sampling also eliminates the possibility of autocorrelation. Okay, you guys still remember what autocorrelation means? If you don't, then revise back. Okay, I think it's also described here in this book. But you know, learning statistics, you will need to know what autocorrelation is. Yeah? Systematic sampling ensures that the sample is spread across the population. Yeah, because you take based on the interval, right? So you cover from the beginning until the end. Yeah? Compared to SRS, because it's random, you know, like maybe somehow by random chance, your sample is more towards the center, more towards the beginning. Yeah, something like that. Okay. Okay. Those are all the strengths, yeah. How about weaknesses? We've covered the first one. And then remember, some combination of elements will have different probabilities. And in fact, if you look at the third box here, the first element really is based on probability. Yeah? And for the subsequent elements, some may have zero chance of being selected. Okay? Principle of independence is violated in that sense because the selection of the next element would depend on the first element. Okay. Yeah, you can imagine this, right? And estimating variance, of course, it will be more complex than for the SRS. Okay, so far makes sense, eh? I mean, that's why it's very important to understand the procedure first. Then only you can think of the pros and cons, because the pros and cons depends on how the selection process is made. Okay, do not attempt to just memorize. Guys, understand so that you can always think. Yeah? Okay. So I think the rest is. I'm not gonna cover the rest here. Okay. There are some examples. Real life examples given here. Okay. Not gonna cover here. So. Cluster sampling. Okay. That's for next week. Since this Wednesday is a holiday. Okay. Right. Okay. Any questions, guys, so far before we move to the textbook exercises? Okay. Systematic sampling should be the probably among the easiest probably, yeah, compared to all. If you look at the formula that we've learned, so it's a lot simpler than stratify. Okay, no questions? Okay, no questions, and let's take a look at this. You probably don't see this. Hang on, let me share. Okay, all right. So the first one, compare contrast between systematic sampling and SRS. We've just been through that, and citing examples appropriately. As I mentioned earlier, I would expect when I look at your team work, right, in your Google Drive, later on, I better not say very familiar examples. Okay, think of, modify a bit lah. You understand scenario, just modify a bit. Okay, citing examples appropriately. Okay, now in terms of effectiveness of systematic sampling, considering random population, ordered population, periodic population. Okay, so the purpose of giving you this is so that you can read up and then, you know, discuss in your team, come up with some notes on this discussion. And then so that it's be easier for you to answer the textbook exercises. If you notice, the textbook exercises also have questions about all this, isn't it? Yeah. And what is repeated systematic sampling? When will it be necessary? And 3 common applications systematic sampling in industry. You could cite the many examples actually, especially in quality control applications. Okay, so I'll put comments on your directly in your file in Google Drive later on. For now, let's take a look at the questions itself. Yeah. Okay, just do this. Now I'm switching to the textbook. Okay, do you guys see textbook now? We're on question 7.20. Still hear me clearly, yeah? All right. Any time that it goes lagging, let me know immediately, yeah? So that we don't lose up time talking but you can't hear. It's a waste of energy. Okay, so what was the questions that you were asked to 7.2? Just go up a bit, 7.2. Okay, right. A corporation lists employees by income brackets, alphabetically within brackets. Oh, okay. So lowest income, or from highest, they list from highest income. So highest income to lowest, again, based on maybe the surname, A to Z. Yeah. If the objective is to estimate the average income per employee, should systematic stratified or SRS be used? Okay, assuming costs are equivalent, you can stratify on income brackets. Discuss the advantages and disadvantages of the three methods. Anything to share here? Should I just call? Oh, hold on. Recall. Okay, how about team? Okay, a rep from team A. Random number. Team A3. Can we have a rep from team A3? And please, not the team leader. It's always team leader always doing things. Now, I want another person, a member, not the leader, from team A3 to answer 7.2, just some parts of it. You may discuss systematic sampling. Let's say systematic sampling. A3? We almost had full attendance. I'm sure we have A3 representative here. Hello, A3. You can type or you can unmute to answer 7.2. Estimate average income per employee. Using systematic, stratified, or SRS. Hey, maybe we should start doing this, huh? Okay. Are you from A3? Okay, why are you saying that systematic is most suitable? Another person from A3 can answer. Because we're supposed to discuss the advantages and disadvantages, right? The pros and cons. So what is it? Okay, others can chip in. Any team can chip in as well. In this context, as in systematic. Maybe your team did not answer systematic. What systematic is? Are you saying that systematic is better than SRS? Oh, we need to compare a bit. Systematic better than SRS? How about team A? Team A5. Oh, I'm doing K equals to 2. A5? Why do you think systematic is most suitable? You wrote there most. That's very strong. Most suitable. Anyone would disagree to that? Anyone would argue to that systematic is most suitable? Hey guys, this is supposed to be a discussion. Don't be afraid to make mistakes, okay? The worst thing to do is not answering, not responding. And if you make a mistake, then I can correct you so that you won't make the same mistake during your quiz or your test later on. Think of it, there's so much seduction here. I don't maybe we should apply, then only we get everyone to answer. Okay, income. Income per employee. Do you think income is normally distributed? I'm sure you have come across income data before. Is income or salary? Salaries, is it normally distributed or most of the time it's skewed? Take note, the CEO is also salary is also included in the employee salary of top management and all. So imagine a factory with the operators, supervisors, engineers, or the managers, the CEO. How would it look like? Do you think it's normally distributed or skewed? You can quickly Google also. This is like quite a common example. Okay. Is it just? Do you guys? Is it? Okay. Are we having some connection issue here? Or is it nobody wants to answer? Still can hear me clearly? I'm not getting any responses in the chat box. Maybe you want to unmute and talk instead. Skewed, okay, yeah, true. Usually, salary and all this is skewed. Yeah, in skewed to the left or to the right. Most of the time, it's skewed to the right, isn't it? Small people have got very high. The tail, remember? Where it's skewed, it follows the tail, isn't it? So some very few people have very high salaries. Yeah, it's right skewed typically. Okay, so if we were to use, do you guys think systematic is the most suitable? Do you think systematic is okay? One by one, systematic better than SRS? Yeah, systematic better than SRS. Everyone agrees with that. Yeah, for the fact that it's ordered, isn't it? Isian, are you asking to annotate the shared content? I'm getting requests here. Should I approve or should I decline? Decline. Okay, no problem. Just checking. No problem. I have no problem. If you guys want to annotate, no problem. Just checking whether it was an error or not. Okay. So, how about stratify? Have you thought about stratification for this particular problem? Would stratification give a better estimate? I mean, does it make sense to actually, again, depending on the company, right? But as I mentioned, if you have, in the company with this, the top management, the operators, all this, right? Like very different salary scale. Does it make sense to do? Does it make more sense to do stratified sampling instead of systematic? Any opinions? So let's say you've got the operator salary, Because you know how average works, right? If you take everything, you divide, and especially if the data is skewed, then you know how reliable your mean be, yeah, the average. Okay, let's get first thing first. SRS, everybody agrees SRS is not the best idea, right? Everyone agrees to that? You can see that why SRS is not the best idea, because the data is ordered, yeah? Systematic, not so bad, yeah? But I want you to think of stratification. Would it make better sense to actually stratify? And when you want to stratify, do you stratify by the certain interval of the salary bracket, or you stratify by the job function or job grade? Something like job grade, eh? Like for example, lecturers also there's different job grades. Yeah, there's tutor, there's pensyarah kanan, and then Professor Madya, and there's professor. So got three different levels. VK7, VK6, VK5. Stratify by job grade maybe makes sense, yeah. Or stratify by the income bracket. No, not yeah, job grade is probably best possible. It makes sense. Okay, but you're right. Systematic sampling is definitely better than SRS. Okay, but if you use stratify, then the estimates can be made for individual brackets or individual job grade. Okay, for that particular strata. So it's most accurate if you use stratify. Okay, but using systematic also no problem. But you're just going to get an average for everything, which is not the most reliable. But the question is asking to estimate the average income per employee, right? Per employee. So it doesn't, they did not say job grade. But if your boss asks you to do this, then you tell your boss this, yes, you can get per employee, but you know, like it is not the most accurate representation. Best is to stratify by certain of the criteria, like maybe job grade or something more meaningful. Okay, anything else to add, guys? Are we okay? 7.2 done, so 7.8. Let's go to 7.8. Oh, 7.8 is calculation. So I'm not gonna go through that because I've given you the answers, right? So you check your working solutions. Check against the answers. If you cannot get the same answer, you know again check with you can check with your friends also, yeah, or you can get back to me. Okay, so 7.8 until what? 7.20 is also calculation. So the next one is 7.2. Okay, 7.22. I'm scrolling down. So Leon, not feeling dizzy. Okay, let's see here. This typical example. Real life, quality control inspector must sample silicon wafers. I was working with silicon wafers in my prior job. Okay, from which computer chips will be made after they are baked in an oven? Its slotted trays containing many wafers are put through the oven, one after another all day long. It's continuous process. Doesn't sleep, the machine continuously running. Now, position on the tray and the time of the day may have important bearings or important effects on the quality of the wafer. So suggest a sampling plan with the goal of being to estimate the proportion of defective wafers. Okay, which team wants to answer this one? 7? Team 7? What do you think? 7.22. Systematic sampling. Which kind do you think? Linear? Secular? Definitely not. Well, I don't think it should be SRS, right? Okay, systematically. Oh, it's many, but somehow the sampling plan should systematically consider position of wafers, position of tray, and also time of the day. However, you select the system systematically, yes, to systematically select, you need to take into account the position, all these factors that affect the quality of the wafers. Okay, that is the answer. Okay, there's no specific, again, because we do not know the details, but whatever sampling plan that you're choosing, yes, systematic sampling sounds good. Yeah. Maybe stratified also, but it depends. It depends. Again, this requires the technology knowledge of this. Yeah? The process expert would know this. But you, as statistician, your advice would be must take into account. It means you must consider the position of wafers on the tray, position of tray in the oven, and the time of the day when it's loaded, when it's baked. Okay, right? So guys, take note. Sometimes when you're being asked for a proposal, that propose or suggestion, you are bound to give based on the limited knowledge that you have. So you can make assumptions or you can just make recommendations like what I just said just now. Okay, you can say that you must consider this and that without actually detailing out what it is. So they must provide you the details. Then you can, discuss further details of the sampling plan. Okay, make sense? Okay, you happy with the answer? We are discussing here. So any other different thoughts that you may have, you can also say it. Okay, guys. 7.22. Okay, let's move 7.23. What's this? Warehouse stacks of automobile batteries that must be sampled for quality inspection. Each stack has a different production date code. Of course, just like roti gardenia also, right? Okay. And the stacks are arranged chronologically. I hate this word. Chronologically. In a chronology. Oh, that's easy. Okay. By date lah, typically. Remember I mentioned to you guys when you do your literature review, arrange in chronological order so that you can see the development, what's been happening here from back then until today. Yeah. Okay, now the stacks are of approximately equal size. Suggest a sampling plan for estimating the proportion of effective batteries. Okay, any team wants to answer this? Each stack has a different production date code. What do you think? Should we stratify? Should we combine stratification and systematic sampling? We can do that, First, you stratify maybe by production date code. Certain date codes together, perhaps. I don't know. And then you from each stratum, or from each stack, perhaps, you can select the sample systematically. Can, right? Because in stratification we also learn, right? For each stratum, you can randomly select either by using SRS or you can also use systematic sampling within each stratum itself. Okay. So one possibility is actually to treat the stacks as strata and then systematically sample from each stratum, okay, to cover the time period of interest. Okay, not? Or hang in there. I don't think I'm gonna give another break before we end at 11:20. Yeah, hopefully that's okay with you guys. Okay, 7.23. 7.24. An auditor is confronted with a long list of accounts. receivable for a firm. She must verify the amounts on 10% of these accounts and estimate the average difference between the audited and book values. Did I give you guys 7.24? Yeah. Okay. Now, three different conditions. What do you guys think? This one. Suppose the accounts are arranged chronologically. Older accounts tend to have smaller values lah for business. Now, should you use systematic or SRS? Come on, this is the easy piece, guys. 7.24, part A. Systematic or SRS? Let's ask him. Okay, good. You answered. Okay, I'm getting answers here privately. Part A, systematic. Yes, that's why they're arranged chronologically, isn't it? So by using systematic sampling, you can make sure that you can make sure that let's say this. It is ordered, so you can make sure that it's the elements in your sample will cover all the different values in this case, all the different values from start until the end. Okay? Compared to SRS could be more centric to the end or the center, we don't know because it's random chance. Okay, good. Now part B. Part B. Arrange randomly. Okay. Which one is better? Systematic SRS or doesn't matter, whichever one is the same? Both. Okay, that's right. For part B, either one. You can choose either one. If systematic is easier, then choose systematic lah. Okay. Because it's arranged randomly. How about part C? Group by department. And then listed chronologically within the departments. Systematic or SRS? There's a question mark. Systematic. C, systematic. We know that definitely it's not SRS, right? Part C definitely not SRS. Systematic. But then how to make it more accurate? Remember the earlier discussion we had? What question was it? 7.22. 7.23 earlier on. We could also consider each department as a stratum, and then we select systematically from that department. Okay, make sense, huh? Because in each department it's arranged chronologically also. And sometimes it's also good to report by the department. But you can merge later on, or you can just take it as a stratified and when you want to compute the estimates. It depends on what the company wants. Okay guys, 7.24 clear? Right, moving on. What else? 7.25. Market share for a certain food product is to be estimated by recording store purchases of the product for certain weeks throughout the year. Okay, certain weeks selected. Discuss the advantages and disadvantages of systematic selection of the weeks for this study. How is it? Again, remember this is talking about purchases, store purchases for certain weeks. Do you think it's got a cycle? Do you think on some weeks, people shop more compared to other weeks? What do you think? Do you think more or less every week people shop about the same? If you notice or not, like shopping malls or grocery stores. Okay lah, you stay home, okay. But logically, well, practically, people will tend to shop more, make purchases after the salary comes in, isn't it? They even have what payday sale, Zalora payday sale. People shop more when the money is in. Right? So, back to this question, the advantages and disadvantages here. Systematic sampling Might be poor if somehow when you select based on the K, right? Somehow the K falls on all peak season, peak weeks, or if the K falls on the valley, you know, the dip in the sales. Okay, I'm saying? Because systematic kan it's got a cycle, so you select, you know, every K, right? If your K happens to be, if it matches the cycle of the sales or purchases in this case, then it will be problematic. You will get the all high sales, or you can get all the low sales. So systematic, you have to watch out for such. Okay, because sales tend to have cyclical patterns. So when you want to design, make sure you take that into consideration. Make sense? 7.25? Yeah. Okay, hang on guys, 3 more minutes, stay with me. Okay, can we move to 7.26? Right, thank you for the response. Okay, now 7.26. Plot yield for a large field of wheat is to be estimated by sampling small plots within the okay, 7.25, repeat again. Okay, you must if your estimation or your systematic sampling might not be a good idea. It might perform poorly if it so happens the weeks that you sample were all the weeks with high sales or all the weeks with lower sales because of the cycle. So if the cycle interval, you know, the gap between the cycles, right, matches your K, your interval, then it will be problematic. You either get all the high sales or all the low sales. That will mess up your estimation. Okay, thanks for asking again. If I think it's not clear, no problem. I can repeat it. Okay. Right, so 7.26, crop yield, large wheat field, estimated by sampling small plots within the field while the grain is ripening. The field is on sloping land with higher fertility towards the lower side. Why towards the lower side, higher fertility? Oh, all the nutrients come like flowing down, isn't it? So it collects at the bottom, right? Okay, suggest a systematic sampling design for the small plots. What do you all think? 7.26. Systematic sampling, easily? Yeah, we can do systematic sampling, right? What would be more accurate? SRS not okay lah because why? It's got ordering, isn't it? The fertility, the lower side is more fertile, meaning that the crop yield hasil tanaman, the crop yield will be higher. So if you use SRS, you know, it may be just like it's sort of imbalance, but if you use systematic, you will cover everything, right, from the top until the bottom. Okay. Next question. Could other sampling designs be used effectively in this case? Take note, effectively. What do you all think? Can we consider stratified or not? So instead of going from top to down, maybe we can go horizontally all around it. So we take the lower as one plot. That means you have to create a bigger plots. You take those at the lower side, and then the middle side, and then the top side. And then you do systematic sampling horizontally instead of vertically. Something like that. Can visualize? Cannot, huh? Okay lah, think about it. Alright, it's already 11:21. It's your right to leave the class now. We've covered everything that I wanted to cover, but if there's anything else, you can ask me now or you can text me later. Okay? Alright guys, thank you so much for your cooperation and participation today. Last call, do we have Wai Hong here?